All right, gentlemen. So today is Tuesday, March the 24th. And today we're going to talk about section 14.2, probability laws govern Mendelian inheritance. Now, in your math classes and maybe in some of your science classes, you've talked a little bit about the rules and laws of probability. Today we're going to concentrate on two rules, two laws that really do affect Mendelian genetics, how inheritance patterns are seen and shared throughout the genome. So, just a couple of notes. First, Mendel's laws that we talked about in the previous lesson of segregation and independent assortment reflect the rules of probability. You got a 50-50 shot of getting this allele and a 50-50 shot of getting the other allele if you are heterozygous, and so on. And so these rules really do follow quite easily with the rules of probability that you've learned in your math classes. So for example, when you toss a coin, right, the outcome of one coin toss has absolutely no bearing on the result of the next coin toss. Okay. When you flip a coin, you got a 50-50 shot of getting heads. Boom. But that doesn't affect what happens in the next flip. Okay. In the same way, the alleles of one gene segregate into gametes completely independently of another gene's alleles. And so, it's the probability of one is in no way related to the probability of the next. Now, if you recall from your math class, these rules are called the multiplication and addition rules. All right, so and they apply quite handsomely to monohybrid crosses. These are the F1 generation crosses that Mendel used, the heterozygous purple flowers, for example. So the multiplication rule states that the probability that two or more independent events will occur together is the product of their individual probabilities. So the for example, if the chance that you're going to get a recessive allele in your gamete is 1/2, and the chance that the other heterozygote is going to put a recessive allele in their gamete is 1/2, then 1/2 times 1/2 gives you 1/4. And therefore, the probability that you're going to be, that your offspring, the F2 generation, is going to be homozygous recessive is 1/2 times 1/2, or 1/4. All right. So probability in that F1 monohybrid cross can be used or can be determined using the multiplication rule. All right. And so segregation in a heterozygous plant is like flipping a coin. Each gamete has a 1/2 chance of carrying the dominant allele and a 1/2 chance of carrying the recessive allele. All right. Same thing comes when you're flipping a coin. You got a 50-50 chance of getting heads and a 50% chance of getting tails. So if we called heads the dominant allele, let's say, and tails the recessive allele, and you flipped two coins, well, then in the first case here, you've got a 1/2 times 1/2, or a 1/4 chance of getting a homozygous dominant individual, a 1/4 chance of getting a heterozygous, plus another 1/4. So these two are obviously both the same. So we have a 50% chance of getting a heterozygote. And then finally,
it's 2 o'clock.
Thank you, Jesus. A 1/4 chance, 1/4 chance of becoming a homozygous recessive individual. Now, the addition rule states that the probability that any one of two or more mutually exclusive events will occur is calculated by adding their individual probabilities together. And so that rule of addition can be used to figure out the probability that an F2 plant from a monohybrid cross will be heterozygous rather than homozygous. And I kind of illustrated that in the previous slide. Let's go back. All right, here, all right, notice 1/4 plus 1/4. That gives you 1/2. And so the multiplication rule gives you all of the numbers that you see circled here, but the addition rule is shown by 1/4 plus 1/4, this is hard, equals 1/2. So you got a 1/4 chance of being homozygous dominant, a 1/4 chance of being homozygous recessive, and finally a 1/2 chance of being a heterozygote. Okay, and that's the multiplication rule and the addition rule as it applies to the law of segregation and the law of independent assortment. So we can use these rules of probability to look at multiple characteristics, not just one trait at a time, but many traits at a time. Right? And of course, the math is going to get a little bit more complicated than just flipping two coins. But a multi-character cross is equivalent to two or more independent monohybrid crosses occurring simultaneously. So if you were to compare the chances of getting blue eyes from two heterozygous parents to the chances of getting freckles from two heterozygous individuals, we can use the laws of probability to figure out what the chances of getting a freckled blue-eyed kid are, or a non-freckled blue-eyed kid, or a freckled brown-eyed kid, or a non-freckled brown-eyed kid. All right, we can figure out all of those numbers. So in calculating these chances, each character is considered separately, and then the individual probabilities are multiplied. And over the course of the next few days, we will go through some examples of this. All right, fellas. Well, happy Tuesday, and I will talk to you tomorrow. Maybe. There we go.